Okay, hello everyone. Today we're going to continue with trigonometric ratio of acute angles. This will be part 2 of this topic. Alright, what are the learning objectives we're going to cover? Okay, we have already covered the first 2 learning objectives in the previous video. So for this video, we're going to look at the use of trigonometric ratio to find the unknown angles in a right angle triangle and to apply trigonometric ratios to solve practical problems. Alright, let's review what we have learned in the previous video. So for these 2 questions, you need to find the value of the unknown in each of the following, and you need to give your answer in centimeters. So you got to find side A and side B. Okay, you should be able to get A for question part A. A will be equals to 11.1 centimeters and B will be 11.5 centimeters. Part B will be A equals to 36.5 centimeters and B equals to 38.4 centimeters. Alright, find the unknown angles of a right angle triangles. So you need to find the value of the unknown in each of the following right angle triangles. So you got to find X. So first you need to label A, O and H. So to recap, H will mean the hypotenuse, A will be the side adjacent to the unknown angle, and O will be the side opposite of the unknown angle, X. So we learn about Tua Caso. So because we already know A and H, we got to use Ca, cosine theta equals to adjacent out of hypotenuse. So cosine X equals to 18 out of 27. So X will be cosine inverse 18 out of 27 and you'll get 48.2 degree, correct to 1 decimal place. Okay, part B, to find angle Y, same thing, got to label the side O, A, and H. And because we know the O and H, we got to use so. Sine theta equals to opposite out of hypotenuse. So sine Y equals to 7.65 out of 14. Y will be equals to sine inverse 7.65 out of 14 and you get 33.1 degree. Correct to 1 decimal place. Okay, next part C. Right, you need to find angle at Z. So label your hypotenuse opposite and adjacent. And because you know O and A, you got to use tangent theta equals to opposite out of A. So tangent Z equals to 16.5 out of 26.8. Z equals to tangent inverse 16.5 out of 26.8 and you get 31.6 degree, correct to 1 decimal place. Alright, next. Diagram shows the triangle ABC. AC equals to 16 meters. AB will be equals to 8.5 meters. Angle DAB will be 42 degree and angle ABC will be a 90 degree right angle. So you gotta find part A, find angle ACB, which is here. Part B will be length of CD. Part C will be length of AD. And part D will be angle CAD. So it's here. Right, to find part A, sine ACB. ACB equals to 8.5, which is opposite of this. Angle is angle ACB out of 16. Opposite out of hypotenuse. So angle ACB will be equals to sine inverse 8.5 out of 16 and you get 32.1 degree. Okay, part B, you got to use the Pythagoras theorem. AC square will be equals to AB square plus BC square. Right, because it's a right triangle ABC is a right angle triangle. So AC is 16 square equals to 8.5 square plus BC square. So you find BC will be square root of 183.75. You don't have to solve this first because later use the exact answer to find the final answer. Alright, because we need to find tangent 42 degree. This 42 degree out of is equals to BD, which is opposite out of adjacent 8.5 meters. Alright, so BD will be equals to 7.6534. Right, just right here. as many decimal places as possible to get the as accurate value at the end. So CD will be equal to BC minus BD. Alright, and you get 5.90 meters. Correct to 3 significant figures. Okay, next. Part C, cosine 42 degree will be equal to 8.5 out of AD. Right, so cosine, that means you are using adjacent out of hypotenuse. So you already know AD. You need to find AD. You need to find AD. So opposite, adjacent out of hypotenuse, and you get AD equals to 11.4 meters. Correct to 3 significant figures. Okay, part D. Cosine angle CAB will be equals to 8.5 over out of 16. Alright, adjacent out of hypotenuse. So angle CAB will be equals to 57.91 degree. And because you want to find angle CAD, so you got to take away the 42 degree. And you'll get 15.9 degree, correct to 1 decimal place. Okay, next, practice 1. So find the value of the unknown angles in each of the following. Right, take some time to do this. Okay, the answer, part A will be 32.4 degree. Part B will be 68.0 degree. Part C 50.5 degree. And part D will be 39.5 degree. They are all in 3 significant figures. Okay, next. Okay, practice 2. Okay, the diagram shows angle ABC. So D is a point. Okay, D is a point on AC such that angle ABD will be equal to 39 degree. BD will be equals to 92 centimeters. And angle BAD will be 90 degrees. So given that the length of BC is 2.5 times as BD, alright, find angle BCA, which is this, and the length of DC, angle DBC, and area of BCD. So this triangle. So part A. Okay, A, to find BC, because it's 2.5 of BD, so 2.5 times 9.2, you get 23 centimeters. So cosine 39 degree will be equal to AB adjacent out of 9.2. So you find AB next. Or AB is 7.1497 centimeters. Once you know AB, sine BCA will be equals to AB opposite out of hypotenuse BC. Alright, then BC angle BCA will be 18.1 degree, correct to 1 decimal place. Okay, next, part B, tangent 39 degree will be equals to AD opposite out of adjacent, which is 7.1497. So AD will be equals to 5.7897 centimeters. So you next use Pythagoras theorem. BC square equals to AB square plus AC square. So find AC will be equals to 21.8605 centimeters. Next to find DC, you take AC minus AD, and you get 16.1 centimeters, correct to 3 significant figures. Okay, next. Part C, cosine ABC will be equals to AB out of BC. So find angle ABC will be 71.89 degree. Once you know ABC, you can find angle DBC. You get 32.9 degree, correct to 1 decimal place. Okay, part D, area of BCA. So remember, half times base times height. So half times DC, which is 16.0708 times AB, which is the height. 7.1497, you get 57.5 square centimeters, correct to 3 significant figures. Okay, next. Okay, application of trigonometric ratios. So trigonometric ratios can be applied to solve real life problems, so like finding the angle elevation and finding the angle of depression. So one is angle of elevation is the angle between the line of sight when you are looking up and the horizontal, while angle of depression is opposite, line of sight when you're looking down and the horizontal. So this diagram shows a man standing at point A. So there's a man here at point A, 42 meters away from the tree CF, and observing the tree. So if the angle of elevation of the top of the tree from the man would be 35 degrees. So this is the angle of elevation. Find the height of the tree. Then the man walks away from the tree to a point B. So he walks further away. So now if the angle of elevation of the top of the tree and the man is 29 degree, how far did the man walk? So you got to find AB. That's the distance the man walk. So these are the key phrases you got to take note. Okay, so finding the height of the tree. So using your tuakaso, tangent 35 degree, it will be equal to CF opposite out of adjacent will be 42 meters. And CF will be the height of the tree, which is 29.4 meters. Correct to 3 significant figures. Okay, next, distance of AB. So you need to find AB, the distance in which the man walked from A to B. So first you find tangent 29 degree will be CF, which is the height of the tree, out of BF, which is the entire distance B to BF. Alright, I get BF is equals to 53.0547 meters. Then to find AB, you just take away the 42. I get 11.1 meters. Correct to 3 significant figures. Okay, practice. Alright, this diagram shows a point, 2 points A, B on the horizontal ground that is 18 meters apart. So DC is the vertical tree and DCA is a 90 degree. So given that DAC is for the 24.5 degree and DBC is 38 degree, find the height of the tree. So these are the keywords you got to take note of, the distance and the angle. So tangent 38 will be equal to CD out of BC. So CD, so tangent 25 and tangent 25.5 degree, 24.5 degree will be equal to CD out of 18 and BC. Okay, so tangent for 24.5 degree is equals to, so replace CD with, from the first equation, CD equals to BC tangent 38 degree. So BC tangent 38 degree out of 18 plus BC. Okay, so then you bring this 18 plus BC to the other side, the left hand side of the equal sign. So 18 plus BC times tangent 24.5 degree equals to BC tangent 38 degree. Okay, then you take 18 times tangent 24.5 plus BC tangent 24.5 degree equals to BC tangent 38 degree. Then you bring this over 10 BC tangent 38 degree on this side. So you bring the BC, the one with the BC one side, and 18 tangent for 24.5 degree to the other side. So you get BC tangent 38 degree minus tangent 24.5 degree equals to 18 tangent 24.5. Then you solve for BC. Right, this is just basically solving for BC. And BC will be equals to 25.197 meters. Okay, so tangent 38 degree equals to CD out of BC. Okay, then you can find CD. Alright, once you know BC. And CD will be the height of the tree is equals to 19.7 meters. Correct to 3 significant figures. Okay, this is a simulated GC O-level exam question. Right, so BC is 88.5 centimeters, ACB is a 90 degree, ABC, angle ABD will be equals to 28 degree, and angle DBC will be equals to 36 degree. So we're going to find length of CD and AB. So part A, tangent 36 degree equal to CD out of 80.5. So CD will be 6.18 centimeters. Correct to 3 significant figures. What about part B? Part B, cosine of angle ABC will be 28 plus 36 will be equal to 8.5 adjacent out of hypotenuse. So AB will be equal to 19.4 centimeters. Correct to 3 significant figures. So these are the mark allocation. Once you get this, you get method mark, and final answer, you get answer mark, 2 marks each for each part. Okay, so that's all. We have covered the last 2 learning objectives for this topic. Okay, so hopefully more practice, you get better for this topic. Okay, that's all. Thank you. Bye-bye.